Hi everyone, my name is Cassie Ng and currently I'm a PhD candidate at Carnegie Mellon University. My training is in two distinct but complementary areas, the learning sciences and cognitive neuroscience. Today, I'm going to share how we can combine these two disciplines to examine changes in executive function and prefrontal cortex connectivity from physically active gameplay in young children. The construct that I'm focusing on is executive function, which is an umbrella term for cognitive processes that subserve goal-directed behavior. These include planning, organizing, resisting distractions, and maintaining attention. In a classroom setting, this would be paying attention to directions and not distracting classmates. In the context of now, this would be paying attention to my talk and not checking your phone or checking your email. Executive function is important because it not only predicts later academic achievement, but also the likelihood of committing crimes and even job and interpersonal success. Several studies have attempted to use computer training interventions or brain game apps to improve executive function, but they find that improvement is shown on the trained task, but this improvement doesn't transfer to novel executive function tasks. Interestingly, in the kinesiology and neuroscience literature, they're finding that intervention studies with adults and special populations show that exergames, video games that require people to interact with the virtual environment through body movements, improve executive function. However, there's little to no research on young children, and more carefully controlled studies are needed of understanding why these exergames are working. To fill these gaps, I took a widely used executive function task known as the flanker task and transformed it into an exergame. The flanker task presents 5 arrows in a row in the form of fish. The goal of the task is for children to press the arrow key that matches the direction of the center middle fish while ignoring the surrounding fish. So children are shown a series of trials of either congruent trials where the fish are facing the same direction, or incongruent trials in which the center fish is facing the opposite direction of the surrounding fish. So this task is difficult for both children and adults because for incongruent trials, your automatic response is to go in the direction of the surrounding fish. So you have to narrowly focus on the center fish while simultaneously ignoring the surrounding distracting stimuli. To preserve ecological validity, I added game interface design features implemented in commercially available exergames. This includes a narrative, player feedback, so positive and negative feedback for correct and incorrect responses, and player progress. So this was actually very challenging because children at this age can't read yet. So I needed to figure out a way that children could understand progress without text. As children get more trials correct, I designed the game so treasures increased in a jar so they could consistently see their progress. To turn this version of the flanker task into an exergame, it was actually projected onto a wall with a connected game mat, so children were responding with the game using their whole bodies. Along with the game features discussed on prior slides, there was also player adaptability. So as children get more trials correct, the response time decreases, and if they went in the wrong direction or took too long, the response time increases, making the game easier and adapting to individual capabilities. This actually keeps children in the zone of proximal development, where the context isn't too easy nor too difficult for their learning capabilities. So children were recruited from a preschool in Pittsburgh, Pennsylvania. At pretest, they were administered 3 executive function tasks and non-invasive neuroimaging. To understand the mechanism driving the effects of exergame play, the following day, children returned to the lab for a 2-day intervention and were randomly assigned to an exergame condition, a cognitive condition, which is the exact same game as the exergame condition, except children were sitting and responded by pressing left or right on the game mat's arrows, therefore decreasing the amount of physical activity. An exercise condition, which is the exact same game as the exergame condition, except the center fish was not surrounded by 4 other distractor fish, to engage children in physical activity with less execution of executive function processes. And also a no-play control group to control for maturation and practice effects. The following day, children returned to the lab for the post-test assessments. Before and after the intervention, children were administered the trained flanker task, another widely used executive function task known as the day-night task, in which children were instructed to say day when shown a sun card and night when shown a moon card. Then the rule actually switches and children are instructed to say day when shown a moon card and night when shown a sun card. Teachers also filled out a clinical assessment of children's behavior in the classroom. And lastly, prefrontal cortex connectivity utilizing functional near-infrared spectroscopy, also known as FNIRS. FNIRS measures changes in blood flow by imaging the brain with low levels of light. This technique actually revolutionized the field because it's non-invasive, and it doesn't require children to remain still and in a confined environment, such as fMRI, and it's less sensitive to motion artifacts like EEG. So it's very useful for neuroimaging research with children. This study specifically looks at the prefrontal cortex because prior literature has shown that the prefrontal cortex development is linked to executive function performance. It also looks at resting state connectivity or correlated activity of brain areas in the absence of a specific task. Resting state has not only been linked with executive function, but also educational achievement and even household income. This study used a validated resting state measure known as INSCAPES, which is a movie paradigm of abstract shapes without a narrative, found to elicit patterns of resting state while actually mitigating fidgetiness in children. So what was found is that children in the Exergame group not only improved on the trained flanker task, but also improved on the transfer executive function day-night task, and teachers rated their classroom behavior better than the control groups. And what I would like to emphasize is that teachers were blind to the condition and were unaware of which condition children participated in. I would also like to highlight that these findings reproduce findings of prior studies and that the cognitive training actually did improve performance on the trained task. The neuroimaging data showed that the Exergame group exhibited increased functional connectivity within and between channels in the prefrontal cortex compared to all the other control groups. Now the question is, how are children's behavioral changes associated with their neurological changes? And what this scatter plot shows is that the more children's prefrontal cortex connectivity increased from pre to post tests, the more their executive function skills actually benefited. So in summary, Exergame's improved performance on a trained executive function task, transferred to a novel executive function task, and generalized to executive function related behavior in the classroom. It also increased neuroplasticity in the prefrontal cortex, meaning the brain can actually strengthen and form new connections, driven in part by children's experiences. And the big picture is that more than 164 million people in the United States actively play video games. That's roughly half the population. And 74% of parents actually believe that video games can be educational for their children. As the use of digital games vastly increases in childhood, at home, and in educational settings, more evidence-based practices are needed. This is particularly important and timely because parents and educators across the nation are attempting to find new ways to keep children physically active and engaged in the wake of stay-at-home orders. Moving forward, the questions I'm proposing for my dissertation research are, how long do these effects last? So I actually have both behavioral and neuroimaging data from these children following them 1 month later. Also understanding how far the effects transfer. So collecting children's scores on standardized academic achievement measures, and also how engagement at both the physiological, such as changes in heart rate, and behavioral level, so self-reports of engagement while playing the games, may affect the outcomes. Current collaborations in communities are crucial for a broader impact. So currently I'm collaborating with Dr. Heather Joseph, a pediatric psychiatrist at University of Pittsburgh that specializes in working with children at risk for ADHD. Children with disabilities that exhibit executive function deficits are the ones that might need it the most, and Exergames might be especially useful for them. I'm also working with Pittsburgh school districts. So this is Mr. Powell, the lead principal of Propel Homestead, where the majority of children are low-income, underrepresented minority students. So this would make having these Exergames available for these children. And I'm also working with Coach Dave Gray, who oversees youth sports for thousands of children in Pittsburgh, to eventually put these Exergames in recreational centers in disadvantaged neighborhoods. Finally, I would just like to thank the Army that made this possible. So the game designers, the research assistants, my advisors, Anna Fisher and Eric Thiessen, Professor Sarah Pickett for actually composing all the music and sound effects for the Exergame, Dr. Frank Fishburne for assisting with the NIRS analyses, And finally, the Children's School, who made this research possible, and the Institute of Education Sciences for funding this research. And finally, thank you for your attention, and I'm looking forward for your questions and your feedback.